Hello guys, hope you are doing well and staying safe at home. Well guys, today I am going to talk about chromosomal abnormality, which is our new activity. The question is, what if we have an extra chromosome for some reason from dad? Or we have a missing chromosome from mom? What if we don't have the normal 46 chromosomes? Now, this case is called chromosomal abnormality. So, chromosomal abnormality is the change in either the number or structure of chromosomes. The two types of chromosomal abnormalities is modification in the number, which is called numerical abnormality, and another type of chromosomal abnormality is structural abnormality, which is in the shape of a chromosome. My concern is numerical chromosomal abnormalities. It means when I have an abnormality in the number of chromosomes, either missing a chromosome, for example Turner syndrome or monosomy 7, or an extra chromosome, for example trisomy 21, trisomy 18, Klinefelter syndrome. We know guys, the karyotype is divided into two types of chromosomes, either autosomes, which are the chromosomes from pair 1 to pair 22, and the last pair, which is the gonosome. So if the abnormality is one from these chromosomes from 1 to 22, we call it autosomal abnormality. So any extra chromosome or any missing chromosome from pair 1 to pair 22, we call it autosomal abnormality. While if the abnormality in the last pair, which is the sex chromosome XY or XX, this is called gonosomal abnormality. A chromosomal abnormality, abnormalities of autosomes. First disease, trisomy 21. We can see guys in pair 21 we have an extra chromosome. This is called trisomy. And because there's an extra chromosome in pair 21, the disease is called trisomy 21, which is also known as Down syndrome. The common name, so trisomy 21 or Down syndrome. All children with trisomy 21 have a short stature, round and flat face, with the upper eyelids that cover the inner corners of the eyes near the nose, almond-shaped eyes, short fingers, undeveloped muscles, flat nose, and one fold line in the palm of the hand. Moreover, these children have mental retardation. Now, I want you to look at the chromosomal formula. It's 47, XY, plus 21 because we have an extra chromosome. It's not 46 anymore, it's 47, XY due to the presence of two non-identical sex chromosomes, X and Y, plus 21 due to the presence of extra chromosome or due to the presence of three copies of chromosome 21 instead of two. So the formula is as following: 47, XY, plus 21. Now moving to the second famous disease, which is this. We can see guys in pair 18 we have an extra chromosome. This is called trisomy, and because there's an extra chromosome in pair 18, the disease is called trisomy 18, which is also known as Edwards syndrome, the common name. So trisomy 18 or Edwards syndrome. Now I want you to take a look at this picture and see how people suffering from this disease, and mainly 95% of these people die in the uterus. They are not even born. Now I want you to look at the formula. The total number of chromosome is 47 due to the presence of extra chromosome. So it's 47, it's not 46 anymore. XX, since the sex chromosome or the last pair of the two sex chromosomes are identical, XX, comma, plus 18 due to the presence of extra chromosome in pair 18. Then we represent this by writing plus 18. So the formula is as following: 47, XX, plus 18. Now, moving to the gonosomal abnormalities. When I see gonosomal abnormality, it means that the abnormality is in pair 23, which contains the sex chromosomes. So, if you have a look, you are going to see that all the autosomes are normal until you see the abnormality in the last pair. Here, the abnormality in the last pair, we have one X and the other X is missing. So the name of this disease is Turner syndrome and it infects female. These females have only X chromosome. Now, this disease is characterized by weak development of ovaries, short height, and of course sterile or infertile. Therefore, the chromosomal formula is 45, X. Okay, 45 due to the missing of one chromosome, X due to the missing X chromosome. Application: chromosomal abnormalities. Documents 1 and 2 present the karyotypes A and B of two persons. The person of karyotype A is characterized by a small size and slightly developed genital organs. The person of karyotype B is a sterile male who shows certain feminine characteristics. Determine the chromosomal abnormalities revealed by each of the two karyotypes A and B. I want you to have a look at this karyotype. Where is the abnormality? Start from first pair. Pair 1, normal, normal, normal. Oh, pair 13. Here, 3 copies of chromosome 13 instead of 2. Then continue. Okay, in last pair, missing of X chromosome. Presence of 1 copy of X chromosome. Also, in karyotype B, there exists 3 chromosomes 13 instead of 2 copies, and in the last pair 3 copies of sex chromosome, 2X and 1Y instead of 2 copies of sex chromosome. Explain why such persons are generally sterile. In a normal person, the number of sex chromosomes is 2. All individuals that possess one more or one less sex chromosome are sterile or infertile. Specify the sex of chromosome of person A. In this karyotype, okay, person A is female since its karyotype includes the sex chromosome X, which determines the feminine characteristics, okay, and does not include the sex chromosome Y, which determines the masculine sex. Write the chromosomal formula for each karyotype. Karyotype B, okay, due to the presence of extra sex chromosome and extra chromosome 13, then the number of chromosome is 48, XXY due to the presence of 3 copies of sex chromosome XX and Y, plus 13 due to the presence of extra chromosome 13. While karyotype A, normal number of chromosome is 46, okay, missing one X, then it's 45, extra chromosome 13, then it's 46 chromosome, X due to the presence of one X chromosome, plus 13 due to the presence of extra chromosome 13. Formulate a hypothesis related to the feminine characteristics of the person of karyotype B. Karyotype B has an extra copy of X chromosome. Then the hypothesis: these feminine characteristics of this person of karyotype B is due to the presence of two copies of sex chromosome X or extra X chromosome. Okay,